So here's a question looking into the national grid. So it says figure 2 shows how power stations transfer electrical power to consumers using the national grid. And you can see the power station, a transformer A before the pylons, transformer B after the pylons before it reaches the consumer. The power station generates electricity at 25 kilovolts. And then transformer A increases the voltage by a factor of 16. So this is important. And it asks, what is the voltage output out of transformer A? So the key thing to note here as well is that the output voltage, your answer, is in the box here is in kilovolts. So we keep the voltage in kilovolts as it is. Yeah, so they've told us before it reaches step transformer A, it's 25 kilovolts. Once it goes through transformer A, it increases by a factor of 16, so 16 times as big. So therefore, to get our answer for the output from there, I'm going to say the output is simply equal to 25, as I said, we keep it in kilovolts, multiplied by 16, which gives us an answer of 400 kilovolts. On to the next question then. It says, why is the voltage increased by transformer A? And it says choose one of the options. So it says it either reduces the energy loss due to heating, to increase the power, or to increase the current. So by process of elimination, we'll say it's not to increase the current, because when you increase the voltage, the current actually goes down. So an increase in potential difference leads to a decrease in current. And then with a transformer, it's meant to be fully efficient in the sense that it's meant to maintain the same power, but do it more efficiently. So it's not increasing the power should stay the same. So that leads us to the answer being that it reduces the amount of energy lost through heating, because if the potential difference increases, the current decreases, so the heating effect is also reduced. The last question, it says, why is it important that the voltage is decreased by transformer B? And it says either less energy is used by consumers, it is safer for consumers, or it reduces consumers' electricity bills. So the main reason to highlight here is that when it was out of transformer A, it's at 400 kilovolts, so 400,000 volts. And that is just simply too high for the consumer to use. It would be way too dangerous. So the simple answer here is that it's safer for consumers to use.